everyone, I'm Haoxi from Newcastle University, School of Engineering. Today my title is the Self-supervised learning for human activity recognized in building environments using BNS data. Yeah, so let's move on. Oh? Yeah, it doesn't happen. So, yeah, okay. Yeah, the short thing of my outlines for my presentation. Yeah, let me introduce in the background. As we see in this building, if there's no human activity happens, it's always, the BNS data always displays in a really stable and a predictable state, which showing really flexible, really stable data. But if we put the human activity inside, so what happens? It will showing that it happens to some really interesting and special fluctuation in the BNS data. And you not just find this fraction in the sensor which the activity happens, but you also could find this fraction in another spaces. Well, this means that maybe it's the activity influence spread to another space, or just because these humans cross these two rooms. So it shows how the occupant activity influences the BNS data, and which is crucially and broadly based. So back to the BNS data. If we compare with the activity data, we can easily find some similar data fluctuations in the BNS data. So that means there's some information maybe hiding in the BNS data. What we do is just to mine it out, but there's also have some problem like the raw sensor data is full of noise and the missing values, so we need to figure it out. So what's the method we need? Data mining and classification is really good methods. So how about supervised learning? Yeah, it's great, it's accuracies, but the labeling data really hard to acquire, because if you want to get labeling data, you need to maybe do some questionnaire or doing the video check, and this maybe invades their privacy. And also rely on the expensive sensor and a wearable device. It's not good. But how about unsupervised method? Yeah, it's also great. You also don't need unlabeled data, but it's lack of time graduality, and also don't have enough information to represent the spatial temporal information. And when it faced to the missing data, it's lack of robustness. So my choice is to self-supervised learning. So why? Yeah. The self-supervised learning could just generate the signal, training signal itself, and don't need labeling data. It's have a highly scannable and generalizes, which could apply in the multi-wire scenarios in the buildings. Is capture rich, fine-grained data representations, and also some self-supervised model could handle with the missing sensor data situation. And for my part, I chose Transformer Masked Autoencoder, which is doing a little enhanced by myself for the multitask learning, which could capture the long-term dependencies in the unlabeled multi-wires BNS data. It can convert data into the classical latent representations, and it also capacity to handle multiple data loss scenario. That's a short introduction of my methodology, the flow chart. We're collecting the data from the BNS system. We tokenize it into the triplets, which including the time, ID, and the value information. We embedded it into the masking autoencoder models, which with the help with the procedural labeling trainings, we can finally get discretization's latent representation. We cluster it, and we finally get event sequences. And these event sequences should be able to represent it to the occupant activity pattern and guide to the BNS control. And it's really easy to do more analysis, better than focus on the raw data for the multi-virus BNS data. So this is a part of my creations for the models. The learnable mask forced the model to reconstruct the missing data, what I call learnable, because the mask is a gradient updates index, but not a 0 or -1 to represent the mask. And also the triplet tokenizes embeddings to capture the relationship across the time and sensors. For the part of the cluster hand and predicts hands. The cluster hand is using to enhance the discretization of latent represented and causing the noise multivariate data. The predict hand is a flexible part. You can just delete it or just add it. It can help to enhance the temporal sensitivity and improve the clustering interoperability. And this is my case study, just to show us introducing for data preprocessing. For the main model, I using the iterative rule to select the best K to guiding the model, guiding the procedural labeling training to get more so discrimination in the data. We're doing the overfitting validation and giving the physical interpretations. So the next data is collecting from the Newcastle University and the USB building, which collecting for 5 or 6 data we got. And also got 5 in a really small meeting rooms with the 5 sensors. I collecting 3 months in the turn times. We also divided into training data and the testing data. We do some pre-processing to linear interpolations and the time frame elements. So I can show you the problem of my model, and also I designed an early stop scheme in case of the overfitting, and also could parallelize the updating the procedural label index parliaments and also the join lost. As I mentioned before, I'm using the sync-halted analysis to determine optimal number of the cluster, and also as with the result, we see the similar cluster distribution, the training test and the learning test is reasonable, so I can say there's no overfitting problems. And also about the missing data sensors data, we're deleting each sensor I mentioned before. It also got a really good question, really good results of the reconstructions, and especially the really key sensor of the occupancy sensor. It shows in the successfully reconstruct of the missing data. And also, I given the physical interpretation of my previous knowledge that it's manual, it's work. And we can find I have arranged it by the activity level. And it's really interesting, the 3, 4, 5 cluster which represented there's no one here, but it also catch some special cluster, maybe showing the influences for another spaces. And so the casting segment could use to do a lot of things, like determine the daily represented, to analyzing the spatial temporal relationship, and even guide the BNS control. I can show you the color coding of my results. You can see it's easy to see the daily circle or the weekly circle, indoor environment parameters. The results align with the distinguishable stage of door environmental change. And also, if we focus on the weekend, we can find there's no one here, but there's a 3 or 2 cluster to showing the influences for the another spaces, which means that cross-space influences has been observed. I can show you there's results. It's not in this conference, but it's my previous result to apply it to the multi-rooms to showing how the activity changed. Or is it 5 o'clock? Need to wait a little bit to 7 o'clock. And so you see, the room has become active, and you can learn a lot of knowledge from itself. That means the possibility of my work. So I'm going to talk about the contribution. My work have no invents problem because it can capture the activity recognize the occupant activity without labeling data and discrete the data from the multivariate BNS data. It also has the ability to data refinement, which using event sequences, but not the row time series data, which increasing the information density. It also has a robustness because of it can face of the multiple scenario of missing data. It also has flexibility. You can add any block you want into the model, and it also can apply to any indoor environments and situation you want it to the multiple type of sensor data, and it's really interesting. If you add more sensor data inside, you will get more cluster results and for more knowledge So the limitation, first one I have already fixed, as you see, to limit spatial and temporal generalizability. And also about the physical interpretation is so subject, I give it myself, but it's always a good question about how to explain the cluster meanings. So, and also a lack of feature engineering that may limit the model expressing. We might find more results if we using the feature engineering. So the future work, I will expand validate to multiple rooms and sensors data. We explore complex spatial temporal based on the event sequences. We integrate with the semantic model to deal with the knowledge, the rules we found in this model. And yeah, that's what I'm talking about my work. Thanks.
Thank you very much.